Hi, my name is Rocco,
And my name's Eric.
and this is a video on the applications of pH.
pH is the short form for the power of hydrogen. It's used to express the concentration of hydrogen ions in an aqueous solution. It's also a logarithmic measure of the acidity or alkalinity of an aqueous solution. In general, the more hydronium there is in a solution, the more acidic, and the more hydroxide, the more basic. pH is measured using various dyes, indicators, and probes, and is rated on a scale from 0 to 14, where 7 is neutral, which can be represented by water, 0 is most acidic, which can be represented by battery acid, and 14 is the most basic, which can be represented by lye. Because this scale is logarithmic, a solution with a pH of 4 is 10 times more acidic than that of one with a pH of 5. Therefore, the method of calculating pH when the molar concentration of hydrogen is given is pH equals the negative of log times the concentration of hydrogen.
So what do we do with all this information?
We all get produce from farms, and running a farm for optimal growth also includes maintaining proper conditions for produce to thrive. That can range from water, sunlight, humidity, a healthy ecosystem, and most importantly, pH. Peas require a pH of 5.8 to 7.0. Anything higher or lower will mean that nutrients in the soil will be unavailable to the peas itself.
What if pH is too high?
If pH is too high, organic matter can be added, which can either be compost or worms, which will naturally lower the pH. Another common method of lowering pH is to add flowers of sulfur, and when this reacts with water, the pH is also lowered.
What if pH is too low?
If pH is too low, lime is added to the soil, and when it comes into contact with water, an alkaline solution is formed, neutralizing the soil to an optimal level. This can also be explained by the chemical equation calcium oxide plus H2O makes calcium hydroxide.
So another application that pH is involved with is pool maintenance. So in many pool maintenance stores, there are bottles with colored indicators used to show values of various measurements, and one bottle tests for pH. Low pH is generally caused by acid rain. High pH is generally caused by wind, sunlight, and bathers. pH affects swimmers' hygiene and comfort. When the water is too acidic, it corrodes metal and causes skin irritation. When it's too basic, it causes scaling on the surface, plumbing, and clouds water. And it also encourages algae growth in uncomfortable places. So in order for pool managers to increase the pH, they add baking soda or pH increaser to raise the pH. The most common cause of consistently low pH is low total alkalinity, which should always be adjusted with sodium carbonate before trying to increase the pH. Adding an acid to the pool water reduces the pH. The most common chemicals used to reduce high water pH are muriatic acid, typically 30% to 35% liquid hydrochloric acid, which is in an aqueous form, and sodium bisulfate, granule or powder pH reducer, which is in a form of a dry acid.
So how else does pH water analysis affect our lives?
In Canada, there are guidelines to drinking safe water by Health Canada. Chlorine is often used as a disinfectant in water treatment plants. It eliminates waterborne diseases such as cholera and also prevents algae and fungal growth. Chlorine in water ranges from 0.04 to 2.0 milligrams per liter. Health Canada recently completed its review on the health effects associated with chlorine in drinking water, as well as taste and odor considerations. Health Canada has classified chlorine as unlikely to be carcinogenic to humans, but slightly toxic. Companies should maintain sufficiently low levels of chlorine at the faucets, ensuring minimal disinfection and an acceptable quality without odors or coloration of drinking waters to consumers. When a diatomic form of chlorine is added to water, it makes hydrogen ions, chlorine ions, and hypochlorous acids. Hypochlorous acid is considered to be more effective at microbial inactivation and dominates at lower pH. By having low pH, for example, 6.5 at a temperature from 0 to 23 degrees, the aqueous solution would contain approximately 92 to 95.4% of hypochlorous acid, whereas pH of 8.5 has 10.8% to 17.5% of hypochlorous acid.
Whenever pH is too high or too low, adding various substances can lead to greater benefits, such as nice peas or comfortable swimming conditions, which in turn makes happiness.
And that concludes our presentation on pH. Bye!